cross product of two vectors. Cross product of A bar and B bar. Again we will take the two vectors A bar and B bar. Given two vectors A bar and B bar. The cross product of two vectors A bar and B bar can be mathematically represented as A bar cross B bar. Again, cross product cannot be applied to a scalar quantity. So if someone asks you to find out A cross 2 or 3 cross B, it is not valid. At this point of time, you may be wondering why I am giving this example of the cross product of vector with a scalar. You will soon realize the significance of this concept when we deal with scalar fields and vector fields. Even though we use dot product and cross product many times in field theory, we will not see A dot B or A cross B, but we will frequently encounter equations like del cross E, del dot D, del cross H. Okay? Understand that they are all similar to dot product and cross product. So there you have to understand what happens if you apply cross product onto a scalar field, or what happens when we apply dot product to a vector field. So that's the reason I want you to understand that this kind of configuration is not possible. So mathematically, how do you represent the cross product of these two vectors A bar and B bar? Say the angle between A bar and B bar is theta. So what is A cross B equal to? A cross B is equal to mod A mod B sin theta. Is that your answer? Is it mod A mod B sin theta? No, it is not mod A mod B sin theta. It is mod A mod B sin theta A n cap, which means the cross product of two vectors is a vector quantity. It is not a scalar quantity. Unlike dot product of two vectors that gave you scalar quantity, this is a vector quantity. So whenever you see cross product of two vectors, immediately you should think about two properties of the resultant. The resultant will have both magnitude and direction. What is the magnitude of this vector? The magnitude of this vector would be mod A mod B sin theta. What happens to mod A n cap? Since mod A n cap is equal to 1, the magnitude of the unit vector is equal to 1. Right? Now what is this A n cap? So A n cap, as we know, it is a unit vector, right? So it has magnitude unity. But when you know that it has magnitude unity, you should also know the direction of this, right? So it is a unit vector perpendicular to the direction of A bar and B bar. It is perpendicular to the plane containing A bar and B bar. It is A n cap. Right? Now, using the same equation, write down the equation for B cross A. B bar cross A bar is equal to mod B bar mod A bar sin theta. And now again you should have a unit vector which is perpendicular to both B bar and A bar. This is also a vector. And what is the magnitude of this vector? So this vector has magnitude equal to mod B mod A sin theta. And the unit vector will also be perpendicular to B bar and A bar. This will be perpendicular to B bar and A bar. If you observe these two vectors, A cross B and B cross A, can we say they are equal? No, they are not equal. They are equal only in magnitude. Mod A mod B sin theta is equal to mod B mod A sin theta, right? But they are not equal in direction. You see, one is along A n cap, the other is along A n bar cap. Now how do you find out what is the direction, whether it is a positive direction or a negative direction? Use the simple concept of right hand rule. What does the right hand rule say? Curl your fingers from first vector to second vector. Take your right hand, curl your fingers from first vector to second vector, and then look at the direction of the thumb. If the thumb is projecting upward, take it as positive. If the thumb is projecting inside, take it as negative. In the first case, if you see, purposefully I took this example in such a way that now when you curl your fingers of your right hand from A bar to B bar, because the first vector is A bar, second vector is B bar, your thumb will be projecting upward. You can experiment yourself. This is called right hand rule. This is called right hand rule. Okay, so that's the reason I didn't tell you, but I already used this right hand rule, and so I used plus A n cap. For B cross A, now you have to curl your fingers from B bar to A bar, right? Don't use left hand, right? Always use right hand. So when you curl your fingers from B bar to A bar, you will see that your thumb is projecting downward. Okay, which means that A n bar cap will be equal to minus A n cap. It is exactly opposite to the direction of A bar, right? So the relation between B cross A and A cross B is B cross A is equal to minus of A cross B. B cross A is equal to minus of A cross B. So they are not equal. B cross A is not equal to A cross B. So the commutative property is not satisfied in this case. Okay. Now can you write down the expressions for x cap cross x cap, x cap cross y cap, x cap cross z cap, also y cap cross x cap, y cap cross y cap, y cap cross z cap, and z cap cross x cap, z cap cross y cap, z cap cross z cap. Keep in mind, x cap, y cap, z cap are unit vectors along x, y and z axis respectively, and they are all mutually perpendicular to each other. So what is x cap cross x cap? Do you want to say it as 1, or before that tell me what is x cap cross y cap? Mod x cap is 1, mod y cap is 1, the angle between them is 90, so sin 90, which is equal to 1. Do you want to say it as 1? X cap cross z cap, do you want to say it as 1? No. X cap cross x cap, the magnitude is 0, but you forgot about the direction, right? So because the cross product of two vectors is a vector quantity. Remember about a vector whenever you see dot product of two vectors. So x cap cross x cap is not 0, it is 0 vector or null vector. Similarly, y cap cross y cap is 0 vector or null vector. Z cap cross z cap is null vector again. And what is x cap cross y cap? So all of us know that the resultant should be z cap. But the problem is whether it is positive z cap or a negative z cap. And how do you verify whether it is positive or negative? Take the help of this right hand rule. Curl your fingers from x axis towards y axis, right? So whichever room you sit, you will have these three coordinates x, y and z, anti-clockwise direction, right? So you consider the three directions of any particular wall in your room, and then curl your fingers from x axis towards y axis. So from one corner to the other corner, and then look at the direction of the thumb. If it projects upward, take it as positive, or else take it as negative. In this case, what will be x cap cross y cap now? X cap cross y cap will be z cap. Curl your fingers. X cap cross z cap will be minus y cap. Y cap cross z cap would be minus z cap. Curl your fingers. Y cap cross z cap would be equal to x cap. Z cap cross x cap will be equal to y cap. Z cap cross y cap is equal to minus x cap. Now you may be getting confused, as in how come we can get positive or negative so fast. Okay. If you know the simple trick, then you got the answer. Of course, this is the procedure. but you need not use the procedure every time, right? Don't sit in the examination and don't curl your fingers like this, like this, like this. Okay, examiner will think this is a mental fellow. So what is a trick? It's not a trick, it's a property of the unit vectors. And what is the property of unit vector? The property of unit vectors is all the unit vectors, they form a right-handed system. Okay, which means you consider these unit vectors x cap, y cap, z cap in anti-clockwise direction. So the orientation of the unit vectors is considered to be positive in anti-clockwise direction. So x cap cross y cap will be equal to z cap, y cap cross z cap will be equal to x cap, z cap cross x cap will be equal to y cap. If there is any interchange, we know the cross product of two vectors doesn't satisfy the commutative property, right? So cross product of a cross b is equal to minus b cross a, or b cross a is equal to minus a cross b, and so you will get a minus.